Alright, so what are we doing today? So we're doing this project. How are we gonna get this going? Okay, so I racked my brain for quite a while trying to figure out exactly what I needed to do in order to make this work. It took me quite a while, but I think I'll just stick with a PowerPoint presentation. So that's what we're gonna go with. We're gonna go with PowerPoint and we're gonna knock this out. You guys ready? Alright. So, obviously, my name is Chris. I'm building your own mission. This is for History of Outerspace. And so we're going to Titan. And why am I doing this? Okay, I do this all the time at work. I don't need to be doing this here as well. This is ridiculous. Alright, so that's not going to work for me very much. Right. Okay, so I play video games. KSP is one of my favorite. I'll just do a Kerbal Space Program mission. That's pretty good. Kerbal Space Program. You build your rockets. You go to planets. You do landers and stuff. Yep, that's what I'm gonna do. Very good at KSP, so we're gonna move on. We're gonna try something different. We're gonna make a crappy MS Paint project, so that's what we're gonna go with. So our mission, we're gonna go to Titan. We're gonna land a boat on Titan. We're gonna science the crap out of Titan. Thank you, Matt Damon, for the quote. So how's this gonna work? Titan plus a boat plus science. Let me explain. We're gonna land at Ligia Mare. It's a giant lake. It's one of the bigger ones. It's got just about everything you could want. It's got plenty of coast. It's got deep areas. It's got shallow areas. It's even got some rivers if you want to get crazy and try and go to our alternative landing location, which is Kraken Mare. It's got a little bit of everything. Our objectives are to identify lake composition, if it's ethane or methane, atmospheric measurements, if it's got volcanoes, what kind of rocks there are, ground-based photography, and we're going to look to see if we can possibly disprove or prove methane-based life. So if there is methane-based life, this might be what it looks like. So our mission is named TOTES, Titan's Orbiting Titular Exploratory Spacecraft. TOTES is so Fletch. TOTES consists of the parent craft, which is for data relay, and has a lander. Specs are about 10,000 pounds. It's about 40 feet long and 10 feet when it's fully deployed. It has two 17-foot solar panels for power output with an RTG device when there's low sunlight, and it keeps the instruments warm. It has the same high gain antenna that the Mars orbiter has as well. So the instruments consist of the high-rise camera taken straight from the MRO, prism spectrometer taken from MRO. This is a gravity field package taken from MRO, and in here is the RTG device to keep it warm, and our super fancy antenna system brought to you by Dish. So what about the lander? Okay, we're getting there, I promise. So Ahab has a lot of instruments. It has everything's taken from Curiosity, basically. It has the exact same stuff we needed. So it has the mass cam, it has HD quality pictures and video. It's got the chem cam to determine chemical composition. It has an environmental monitoring system with a directive called Al Roker. It uses to predict dangerous weather patterns and drop anchor to ride out the waves as needed. Has 4 HAZ cams. They all face north, south, east, and west. Titan Geospatial Observation Primary Resonant Observatory, Titan GoPro. This is basically Curiosity's MOLLE camera, and it acquires microscopic images of the shorelines and what's underwater too. Has the sample analysis at Titan, and it has a high gain antenna stolen from the Huygens probe. So this is our boat. It's about 2,000 pounds. This is our initial landing configuration. It's going to land from the Curiosity Sky Crane. So here's our different instruments. There's the EMS by Al Roker. Here's the high gain antenna. Here's the propulsion system. This has 360-degree directional thrust, so we can do whatever we need to. Here's our cool mass cam. And then internally it has the computer, sample analysis system, and Ahab's beach buggy robot, and that sits in the sky right there. All right, so this is our beach landing system, and our BBR comes out of here. Beach buggy robot comes out of here. He rolls down the little ramp, and he gets on the beach and does what he needs to with the tools he has. This raised bow is good for beaching conditions, and that's what we need. This is the exact same rover as Sojourner on the Pathfinder mission. It just has upgraded beach compatible wheels. We're assuming it's going to be soggy and wet. We don't want it to get stuck. This is completely battery operated. It does not have solar panels. So we're going to get there on the back of the SpaceX Falcon Heavy. Basically, it's 3 Falcon 9s strapped together. I've seen conflicting reports on how many pounds this can do, between 29 and 40,000 pounds. So we'll see when they actually take flight. So with this, we'll put everything together. You have your heat shield, your boat, your sky crane, you have totes. They're going to throw it together. It's going to go into the payload bay here, and we're going to launch. Totes is going to do its first Venus flyby. Then it will do its second Venus flyby. Then it will do its Earth flyby. Then we're going to do Jupiter's flyby. And finally we'll get to Saturn. We'll do a D-orbit burn, or orbit burn. And now we're going to go ahead and try and land on Titan. So the landing procedure is going to be as follows. The whole landing package is going to come in here. It's going to be using the heat shield because it's going to be penetrating atmosphere at high speed, so it'll build up a lot of heat. Once it slows down enough, parachute will deploy, slowing down the craft. This will drop off. The heat shield will drop off. Now we'll go down to descent mode. It'll descend for a couple hours, just like the Huygens probe did. Once we're about 10 to 20 meters up, the parachute will cut away. The thrusters will fire on the sky crane. Sky crane will lower gently the boat into the lake. It will then cut the umbilical cord and it will fly away and crash into the coastal region, hopefully for us to explore later. Here's our Beechcraft. The extending platform will let out the BBR, which is right here. Again, he has no solar panels because there's not enough there's too much atmosphere. It's too thick. Can't get any sunlight. The unit is completely battery operated, and when it's low in power, it comes back and redocks in the sky right there. At this time, it'll take samples. It'll try and get some dirt. It'll try and bring it back to the Ahab here for analysis, and then the BBR can come and go as it needs to, and then the Ahab can drive to another location for further analysis as needed. Up here's Totes, catch in the data, send it back to Earth, and this would be just Saturn on the horizon. Hopefully you'll be able to catch a picture like that. Maybe one of these guys. So that's pretty much it. That is my presentation, And there's more technical information in my Word document. Thanks.